learners, I welcome you all to this session on distributed and parallel data mining algorithms. Before going into distributed parallel data mining algorithms, we need to know what is data mining. Data mining is a process of non-trivial extraction of implicit, previously unknown and potentially useful information from data in databases. And naturally, data mining is termed as knowledge discovery. And you would like to know what is knowledge discovery. Now, we will see the life cycle of data mining. The entire life cycle of knowledge discovery includes steps such as data cleaning, data integration, data selections, data transformation, data mining, pattern evaluation and knowledge presentation. This picture shows the steps involved in data mining. So, we have the data in the database. In that we do a selection, then a transformation and then we do a data mining and then we evaluate the patterns and from the patterns we do a knowledge discovery. Now, let us see what is data cleaning. Data cleaning is to remove noise and inconsistent data, that is data which is not needed for the analysis. Data integration is to combine data from multiple data sources such as a database and a data warehouse. After integration, we will do a selection. So, data selection is to retrieve data that is relevant to your task. After you select the data, you have to do the transformation. So, data transformation is to transform the data into appropriate forms. After you do the transformation, the next step is data mining. What is data mining? It is to apply intelligent methods to extract data patterns. After we have done with data mining, the next step is pattern evaluation. Pattern evaluation is to identify the truly interesting patterns based on some interestingness measures. And there are several interestingness measures we will see later. Now, knowledge evaluation is to visualize and present the mined knowledge to the user that will be of interest to them. So, in data mining techniques which we will see here are association rule mining, classification, clustering, sequential pattern mining and many more methods. Next we can see what is distributed data mining. First we need to understand what is distributed computing. So, distributed computing is that it plays a vital role in the data mining process for so many reasons. The first reason is data mining often requires large amounts of resources in storage space and computation time. So, to make a system scalable, it is required to develop mechanisms that distribute the workload among several sites in a flexible manner. With that, we will move to the second point now. The second point is data often inherently distributed into several databases, thereby making a centralized processing very inefficient and prone to security risks. So, distributed data mining will help us to explore the techniques of how to apply data mining in a non-centralized way. Data mining algorithms deal with simple data formats, for example, typically flat files, and there is an increasing amount of focus on mining complex and advanced data types such as object-oriented, spatial and temporal data. Now, we will look into the other aspect of this. Another aspect of this growth and evolution of data mining systems is the move from standalone systems using centralized method and local computational resources. As data mining technology matures and moves from a theoretical domain to the practitioner's arena, there is an emerging realization that distribution is an important factor, and that factor needs to be accounted for. Databases in today's information age are inherently distributed. So, as you can see, there are many examples. For example, in a banking data, the data is naturally distributed. And in organizations that operate in global markets, it needs to perform data mining on distributed data sources. And the distributed data sources are of two types, that is homogeneous or heterogeneous. and they require cohesive knowledge from this data. Such organizational environments are characterized by a geographical separation of users from the data sources. That is, the user will not be in the same place where the source is existing. This leads to an exorbitant communication cost. Therefore, it is clear that traditional data mining model involving the co-location of users, data and computational resources is inadequate, especially when dealing with distributed environments. So, the development of data mining with this dimension leads to the emergence of distributed data mining. Broadly speaking, data mining environments consist of users, data, hardware and the mining software, and the software includes both the mining algorithms and any other associated programs. Next, we will see what are all the things addressed here. A distributed data mining addresses the impact of distribution of users, software and computational resources on the data mining process. There is consensus that distributed data mining is the process of mining data that is partitioned into one or more physically or geographically distributed subsets. The factors which lead to the emergence of distributed data mining from centralized data mining can be seen as follows. So, the first factor would be the need to mine distributed subsets of data and the integration of which is non-trivial and expensive. The another factor which you have to keep in mind is the performance and scalability bottlenecks of the data mining. Moreover, distributed data mining provides a framework for scalability which allows the splitting up of larger data sets with high dimensionality into smaller subsets, and naturally it will require computational resources individually when you split larger data sets into smaller data sets. Next, we can know about DDM, that is distributed data mining. It is a branch of the field of data mining that offers a framework to mine distributed data, paying careful attention to the distributed data and the computing resources. Hence, in the DDM literature, there are two ways in which data is distributed across sites. One is homogeneously and the other one is heterogeneously. Both viewpoints adopt the conceptual viewpoint that the data tables at each site are partitions of a single global table. Now, we will see the homogeneous case. In the homogeneous case, the global table is partitioned horizontally. The tables at each site are subsets of the global table, and moreover, they have exactly the same attributes. This is a typical scenario of a homogeneous case. Next, we will see the heterogeneous case. In the heterogeneous case, the table is partitioned vertically and each site contains a collection of columns, and the sites do not have the same attributes. However, you have to note that each tuple at each site is assumed to contain a unique identifier to facilitate the matching. And it is important to stress that the global table viewpoint is strictly conceptual. Now, since we have an idea about DDM, let us look at what is parallel data mining. In general, data mining is the automated analysis of large volumes of data looking for the interesting relationships and knowledge that are implicit in large volumes of data. When data mining tools implemented on high performance parallel computers, then we can analyze massive databases in a reasonable time, that is simultaneously. So, faster processing also means that users can experiment with more models to understand complex data. High performance makes it practical for users to analyze greater quantities of data that in turn yield improved prediction. So, here we are generating different strategies and techniques to exploit parallelism in data mining algorithms. In particular, we have designed and implemented a parallel version of AutoClass, that is called as P-AutoClass, on distributed memory, that is MIMD parallel computers. And this implementation is portable on a large number of parallel architectures, and it demonstrates to be scalable in terms of speeding and scaling. So, thereby you can increase the speed as well as you can increase the size. Now, let us see a paper which describes this. A paper that describes the system and the implementation will appear on IEEE Transactions on Knowledge and Data Engineering. Now, let us look at what is the parallel and distributed data mining. The voluminous and high dimensionality of data sets typically available as input to the problem of association rule discovery makes it an ideal problem for solving multiple processes in parallel. The primary reasons are the memory and the CPU speed limitations which are faced by the single processor. Since there are limitations in the single processor only, we are trying a parallel processing, as it is critical to design efficient parallel algorithms to do this task. Another reason which you have to have in your mind is that for parallel algorithms comes from the fact that many transaction databases are already available in parallel databases, or they are distributed at multiple sites to begin with. The cost of bringing them all to one site or one computer for serial discovery of association rules can be reasonably expensive. And moreover, for computer intensive applications, parallelization is a means for improving performance and achieving scalability also. A variety of techniques used to distribute the workload involved in data mining over multiple processes. The task parallel algorithms assign portions of the search space to separate processes, so that all the processes can work together at the same time. This task parallel approaches is divided into two groups. The first group is based on a divide and conquer strategy that will divide the search space and assign each partition to a specific processor. On the other hand, the second group is based on a task queue that dramatically assigns small portions of the search space to a processor whenever it becomes available. A task parallel implementation of decision tree induction will form tasks associated with branches of the tree. Hope you have an idea about the decision tree. A divide and conquer approach seems a natural reflection of the recursive nature of the decision tree. However, the task of parallel implementation suffers from load balancing problems that is caused by uneven distribution of records in branches. Hence, the success of a task parallel implementation of a decision tree seems to be highly dependent on the structure of the data set. Hence, you have to pay close attention to the data set before you implement a parallel mining algorithm. The second class of approaches called data parallel distributes the data set over the available processes. Data parallel approaches come in two flavors, that is a partitioning based on records that will assign non-overlapping sets of records to each of the processor. The other method is, that is alternatively a partition of attributes will assign sets of attributes to each of the processor. Thereby, the attribute based approaches based on the observation that many algorithms expressed in terms of primitives will consider every attribute in turn. If attributes distributed over multiple processes, these primitives will be executed in parallel. For example, when constructing a decision tree, at each node in the tree, all independent attributes will be considered in order to determine the best split at that point. There are two basic parallel approaches in recent times, that is, one is work partitioning and another one is data partitioning. Now, let us have a look at what is work partitioning. These methods assign different view computations to different processes. Consider for example, the lattice for a 4-dimensional data cube. If a name assigned to the dimensions as ABCD, 15 views need to be computed. Given a parallel computer with P processes, work partitioning scheme partitions the set of views into P groups and then it assigns the computation of the views in each group to a different processor. Thereby, the work will be distributed across 15 processors. But the main challenges, as you have to note here, are the load balancing and the scalability. Now, we will see what is data partitioning. These methods work by partitioning the raw data set into P subsets and stores each subset locally on one processor. All views computed on every processor, but only with respect to the subset of data will be available at each processor. So, a subsequent merge procedure is required to agglomerate the data across the processors. Hope you have understood this concept. The advantage of data partitioning method is that they do not require all the processors to have access to the entire raw data set. They will have access to only the subset. Each processor only requires a local copy of a portion of the raw data that can be stored on its local disk. This makes such methods feasible for shared nothing parallel machines. The next question you may ask naturally is, why parallelized data mining? Data mining applications fall into two groups based on their intent. In some applications, the goal is to find explanations for the most variable elements of the data set, that is, to find and explain the outliers. But in some other applications, the goal is to understand the variations of the majority of the data set elements with little interest in the outliers. Scientific data mining seems to be mostly of the first kind, whereas commercial applications seems to be of the second kind, that is, you will try to understand the buying habits of most of the customers. In applications of the first kind, parallel computing seems to be essential. In applications of the second kind, the question is still open because it is not known how effective sampling from a large data set might be at answering the broader questions. Now, we will get an idea of why we need parallel computing. So, parallel computing thus has considerable potential as a tool for data mining, but it is not yet completely clear whether it represents the future of data mining. As we have got an idea of the concepts in the parallel data mining, we will look into the technologies. The first one is parallel computing. Single systems with many processors work on same problem. But in distributed computing, many systems loosely coupled by a scheduler to work on related problems. Then we will see what is grid computing. Here, many systems are tightly coupled by software, perhaps geographically distributed, and are made to work together on single problems or on related problems. Now, let us see the properties of algorithms for association discovery. Most algorithms for association discovery follow the same procedure, that is based on sequential a priori algorithm. And hence, the basic idea is to make multiple passes over the database, and thereby you can build larger and larger groups of associations on each pass. And naturally, the first pass determines the items that occur most frequently in all the transactions in the database. And each subsequent pass will build a list of possible frequent item tuples based on the results of the previous pass, and then again it will scan the database. And doing so, it will discard those tuples that do not occur frequently in the database. It will yield only the most frequently occurring items. The intuition is that for any set of items that occurs frequently, all subsets of that set must also occur frequently, and that is the understanding. For larger association sets, this algorithm and its derivatives must make many passes over a potentially enormous database. It typically implemented using a hash tree, a complex data structure that will exhibit very poor locality. Although there exists workable sequential algorithms for data mining, there is a desperate need for parallel solution for most realistic sized problems. And hence, the most obvious argument for parallelism revolves around the database size. The databases used for data mining are typically extremely large and often contain the details of the entire history of a company's standard transactional database. And as you note, these databases grow past hundreds of gigabytes towards a terabyte or even more, and hence it becomes nearly impossible to process them on a single sequential machine. For both time and space reasons, we have to consider this parallel data mining. No more than a fraction of the database can be kept in main memory at any given time, and hence the amount of local disk storage and bandwidth needed to keep the sequential CPU supplied with the data is also enormous. Additionally, with an algorithm such as a priori requires many complete passes over the database, and that is the actual running time required to complete the algorithm becomes excessive, and we need to keep this in mind when we run such algorithms. The basic approach to parallelizing association discovery data mining is through database partitioning. Each available node in the networking environment is assigned a subset of the database records and computes independently on that subset, and usually using a variation on the sequential a priori algorithm. All the parallel data mining algorithms require some amount of global all or all-one communication to coordinate the independent nodes. Now, let us look at the problems in developing parallel algorithms for a distributed environment. There are several problems in developing parallel algorithms for a distributed environment with association discovery data mining, which is described in this research work. Those are, the first one is the data distribution. One of the benefits of parallel and distributed data mining is that each node can potentially work with a reduced size subset of the total database. A parallel algorithm in distributed environment must effectively distribute the data to allow each node to make independent progress with its incomplete view of the entire database. Now, let us look at I/O minimization, that is input output minimization. Even with good data distribution, parallel data mining algorithms must strive to minimize the amount of input output they perform to the database. Now, let us see how to do the load balancing. To maximize the effect or efficiency of parallelism, each workstation must have approximately the same amount of work to do. Although a good initial data distribution can help provide load balancing with some algorithms, periodic data redistribution is needed so that we can obtain good overall load balancing. How to avoid duplication? Ideally, no workstation should do redundant work, and by this way we can avoid duplication and the work already performed by another node. Now, let us see the other problem, that is how to minimize the communication. An ideal parallel data mining algorithm allows all workstations to operate asynchronously without having to stall frequently for global barriers or for communication delays. The next issue is maximizing the locality. As you can see, in all performance programming, high performance parallel data mining algorithms are designed to reap the full performance potential of hardware, and this will involve maximizing the locality for good cache behavior, utilizing the machine's memory bandwidth as much as possible. Achieving all of the above goals in one algorithm is nearly impossible, as you know, and as there are trade-offs between several of the above points. And also you have to remember that existing algorithms for parallel data mining attempt to achieve an optimal balance between these factors. Algorithms in parallel and distributed data mining is the area which we have to concentrate on. The major algorithms used for parallel and distributed data mining are: one is count distribution. This algorithm achieves parallelism by partitioning the data. Each of the n workstation gets 1 by nth of the database and performs an a priori like algorithm on the subset. And at the end of each iteration, however, is a communication phase. And in this communication phase, the frequency of item occurrence in the various data partitions will be exchanged between all the workstations. And hence, this algorithm gives a trade-off of I/O and duplication for minimal communication and good load balance. Each workstation must scan its database partition multiple times and maintain a full copy of the data structures used, but only require a small amount of per iteration communication and as a good distribution of work. The next algorithm which we will see now is a data distribution method. This algorithm is designed to minimize the computational redundancy and maximize the use of the memory bandwidth of each workstation. And naturally, it works by partitioning the current maximal frequency item set candidates amongst the workstations. Thus, each workstation examines a disjoint set of possibilities. However, we have to note that each workstation must scan the entire database to examine its candidates. Moreover, this algorithm trades off a huge amount of communication for better use of resources in order to avoid duplicated work. The next algorithm which we can discuss is candidate distribution. This algorithm is similar to the data distribution in that it will partition the candidates across workstations, but it attempts to minimize the communication by selectively partitioning the database such that each workstation has locally the data needed to process its candidate set. It does this after a fixed number of passes of the standard data distribution algorithm. This trades off duplication, that is, the same data may need to be replicated on more than one node, and poor load balancing also, that is, after redistributing the data, the workload of each workstation may not be balanced in order to minimize the communication and the synchronization. And naturally, the effects of poor load balancing will have its effect, but will be mitigated somewhat. Hence, this global barrier are there at the end of each pass and they are not required. And as we have seen these three algorithms, we can look into another method, that is the ECLAT. This sophisticated algorithm will avoid most of the trade-offs above by using an initial clustering step to pre-process the data before partitioning it in between the workstations. And thereby it will achieve many of the benefits of the candidate distribution without the cost. Little synchronization or communication is needed since each node can process its partitioned data set independently. A transformation of the data during partitioning allows the use of simple database intersections rather than hash trees, and thereby this will maximize the cache locality and memory bandwidth usage. The transformation also drastically cuts down the I/O bandwidth requirement by only necessitating 3 database scans. Now, let us have a look into the role of the intelligent agents in distributed data mining. First, we need to understand what is an agent. Agents are defined as software or hardware entities that will perform some set of tasks on behalf of the user with some degree of autonomy. Therefore, in order to work for somebody as an assistant, an agent has to include a certain amount of intelligence, that is the ability to choose among various courses of action, plan, communicate, adapt to changes in the environment and learn from experience. So, in general, an intelligent agent is described as consisting of a sensing element that can receive events, a recognizer or classifier that determines which event occurred, a set of logic ranging from hard-coded programs to rule-based inferencing, and a mechanism for taking action. Now, we have seen what is an agent. Now, we will see what is a data mining agent. A data mining agent seeks data and information based on the profile of the user and the instruction the user is giving. A group of flexible data mining agents can cooperate to discover knowledge from the distributed sources. Remember that they are also responsible for accessing the data and extracting higher level useful information from the data. And therefore, a data mining agent will specialize in performing some activity in the domain of interest for you according to the area in which you are working. Agents can work in parallel and share the information they have gathered so far. This is a typical advantage of an agent. IA in general, called as the intelligent agent, refers to a software agent that exhibits some form of artificial intelligence. And according to Ulrich, intelligent agents are defined as agents capable of flexible autonomous action to meet their design objectives. There are several design objectives. Let us see the first one, that is reactivity. This is to perceive and respond in a timely fashion to changes occurring in their environment, in order to satisfy their design objectives. A changed environment may affect the agent's goal or assumptions that form the basis for a procedure that currently executed, and a different set of actions may have to be performed. The next feature is proactiveness. What do you mean by proactiveness of a IA? It is the ability to exhibit goal-directed behavior by taking the initiative, responding to changes in the environment in order to satisfy their design objectives. The another important feature we have to look at here is sociability. This is the capability of the agent to interact with other agents, especially the software and the humans, through negotiations or cooperation to satisfy their design objectives. During the mining process, you need to be careful that the mobile intelligence agents are used, as it keeps monitoring the different workstations in the geographically distributed areas. Having seen what is a IA, that is an intelligent agent, let us have a look into the Padma architecture. So, the Padma architecture is an agent based architecture for parallel or distributed data mining. And the goal of this effort is to develop a flexible system that will exploit the data mining agents in parallel. And hence its initial implementation uses agents that are specialized in unstructured text document classification. A Padma agent is used for dealing with numeric data that are currently under development. And you need to know the main structural components of Padma to use it effectively. The first main component is a data mining agent. The another component is facilitator for coordinating the agent. The next one is the user interface. Agents work in parallel and share their information through the facilitator. Now, already we have seen what is DDM. DDM aims at extraction of useful pattern from distributed heterogeneous databases in order, for example, to compose them within a distributed knowledge base and use for the purposes of decision making. Rough set theory is a new mathematical approach to imperfect knowledge. Let us see how it is used here. Philosophers, logicians and mathematicians have tackled the problem of imperfect knowledge for a longer time. And recently it became also a crucial issue for computer scientists, particularly in the area of artificial intelligence. And there are many approaches to the problem of how to understand and manipulate the imperfect knowledge. Czeslaw Pawluk developed a rough set theory in the early 1980s. Let us see what is rough set theory. The rough set theory deals with the classification of discrete data table in a supervised learning environment. Although in theory rough set deals with discrete data, the rough set theory commonly is used in conjunction with other techniques to do discrimination on the data set. And the main feature of rough set data analysis is non-invasive, and it has the ability to handle qualitative data. And naturally this fits into most real life situations nicely. And the rough sets have seen light in many researchers, but seldom found its way into real world application. Knowledge discovery with rough set is a multi-phase process, and it consists of many phases. The first one is discretization, and the next one is redux and rules generations on training set. Using mathematical models is beyond increasing performance of the system. Moreover, it helps knowledge workers in deeper analysis of business and underlying product or the domain. And naturally, this will increase awareness in the company, knowledge transfer within the company, and higher desire to learn better things. There are many techniques like regression and classification, which are some of the popular mathematical models. However, predictive analytics is not limited to these methods. We have to apply the methods based on our own problem. Now, let us see the applications in parallel and distributed data mining. The technology of parallel and distributed data mining can be applied on several real-time applications. Let us see the major applications. One is the credit card fraudulent detection, which you will be very much aware. The second one is intrusion detection. Another one is business analysis, which is used for prediction. Another important application is financial application, and others are astrological events and anomaly detection. Now we have had a good idea about what is data mining, what is parallel data mining, and how it is applied. Let me give you a summary. Parallel data mining deals with tightly coupled systems including shared memory systems, that is SMP, distributed machines DMM, or clusters of SMP workstations called clumps with a fast interconnect. DDM on the other hand deals with loosely coupled systems such as cluster over a slow Ethernet local area network. And it also includes geographically distributed sites over a wide area network like the internet. And the main differences between PDM to DDM are best understood if we view the DDM as a gradual transition from tightly coupled fine grained parallel machines to loosely coupled medium grained LAN of workstations, and finally a very coarse grained WAN. There is in fact a significant overlap between the two areas, especially at the medium grained level where it is hard to draw a line between them. In another view, we can think of PDM as an essential component of a DDM architecture. An individual site in DDM can be a supercomputer or a cluster of SMPs or a single workstation. In other words, each site will support PDM locally. Multiple PDM sites constitute DDM, much like the current trend in meta or supercomputing. Thus, the main difference between PDM and DDM is that of scaling, communication cost, and data distribution. While in PDM, SMPs can share the entire database and construct a global mined model, in DDMs generally partitions the database but still generate global patterns or models. On the other hand, in DDM, it is typically not feasible to share or communicate the data at all. Local models built at each site and are then merged or combined via various methods. PDM is the ideal choice in organizations with centralized data stores, while DDM is essential in cases where there are multiple distributed data sets. In fact, a successful large-scale data mining effort will require a hybrid of both PDM and DDM approach, where parallel techniques used to optimize the local mining at a site and where distributed techniques are used to construct global or consensus patterns or models, at the same time minimizing the amount of data and results communicated. Hope you had an overall idea of what is PDM, DDM, a comparison of their pros and cons of how they can be implemented. Happy learning to you all. Thank you.